assessment asks us why only starting material is recovered when this epoxide is treated with this organolithium reagent. The reason is that this molecule has an alcohol in it, and this alcohol has an acidic proton, and the acidic proton is the most electrophilic site in this molecule. The organolithium would react with the acidic proton on the alcohol to form an alkoxide, and then after acid quench, the alkoxide would get protonated back to the alcohol, and the epoxide would never get reacted. We can work around this by using a protecting group strategy on the alcohol. So if instead our first step is not to treat with this organolithium reagent, but instead to treat this alcohol with a protecting group. So we take this alcohol and we treat it with, let's say, triisopropyl silyl chloride and triethylamine. Then we could protect this alcohol as a silyl ether. Now that the alcohol is protected, we could react it with the organolithium reagent. Now the organolithium reagent can't react with an acidic proton because the alcohol is protected, so it will open up the epoxide. And we end up with our alcohol and a protected alcohol. And now we can deprotect the alcohol, returning it back to its original alcohol form and forming our desired product. And we do that with tetrabutyl ammonium fluoride in water as a solvent. So this three-step protecting group strategy could form the desired product as long as we protect the alcohol first.